Hello, welcome to the 10th tutorial. This one will be on 3D graphing. We'll look at just the basic command and basic graphing and also related graphs because there are many other types of graphs that people often use to help understand their functions a little bit more fully. And of course, there are many useful options that people like to make use of to see their graphs more clearly. So let's get started. Just first section here, basic graphing. The command we're using is plot 3D. In this case, just a nice example, sine of xy. Don't forget the space between the x and y. But because x and y are both domain variables, I better have values for each of these. And we'll just look at the basic graph here. By default, that's what we get. Looks nice, nice smooth graph. Next example. exp, that's e to the all of this stuff as the exponent. Sometimes it's just much easier to write it this way, but I could certainly use the special e and put all of that in the exponent. But again, I have values for x and y. We'll look at this graph. All right, well, that comes out to be a little bit more interesting. And of course, the range is chosen automatically by the Wolfram language, but I can control that, just as we did with 2D graphing. Now, here it cuts this off, just it shows these gray spaces just where it's hitting the top of our box. All right. Now, let's look at another graph here. Cosine of x squared plus y squared. Interesting thing. All right, now, if I move a little bit more useful information here, if I move the cursor over the graph, it changes to a different form. And if I hold down this and drag the cursor over this, I can move it around and look at this from all sorts of different angles. In addition, I can also hold down the Alt key and my cursor changes again, and I can hold this down and drag my cursor and zoom in and out. Those are really nice at times just to get a much better look at your graph. Okay, options. Options for plot 3D. We'll use this command again and plot 3D. Close that off. Okay, lots of things we can look at here. Boundary style, box ratios, controller path. Well, that may be a different issue you don't want to look at right now. We're going to skip that. Filling, format type, image size, all sorts of things. Many more here than we had for 2D graphing, which should not really be a surprise. Okay. You can play with any of those. You can look them up in the help system if you're interested. Let's come down to look at another option. This function is very messy. And so if I'm near 3, went from 0 to 3 for both x and y, but this value gets very large, and so sine is going up and down very quickly. And yeah, you can kind of see what's going on, but it's just uneven. All right, so one very useful command is to add plot points. And here I've chosen 50, but you can choose your own value to put in there. And it's what do we start with and then kind of fill things in. Well, if I do that, I get a much smoother graph, still a little bumpy around some of the edges in there, but still much smoother. It will slow down the graphing, so you don't want to use that all the time, but occasionally it is very helpful. All right, graphing two functions at once. Same thing we did with 2D graphs. We put both of our functions inside one set of curly braces. And in this case, I put in a plot range also for my Z values. Okay, as default, just with 2D, I get two different colors here. And I can move this around and look at it. That's fine. Well, I can also do some other things. There's a plot style here, and I've used opacity and different levels of that for my first graph and my second graph. And so they're much clearer and I can see a lot more of what is going on. May not be particularly necessary for these two graphs, but for certain functions, opacity can be very nice and helpful. I can also change colors, just a couple other examples here. Color function, and also then a different color function. So a couple options in here. Okay, I just think that's pretty with the blue, green, yellow. Rust tones, we expect to see oranges and browns, and yep, that's what I get. But I still have the opacity in there as well. So just as with 2D, there are lots of other colors and changes you can make to these graphs. All right, some related graphs that people often use to help see functions more clearly. Let's look back at this in the basic graph again first to see what it looks like. So we're at 0 in here, you go ups and downs in different directions. Contour plot. Now, so in this case, the command changes, but the rest of the information I have there is exactly the same. All right, so I get sections in here. If I look back at this again, this is higher and I get lighter colors, and then it goes way down and I get darker colors. Now, in this, just by default, if I come over each of these lines, it will tell me what the values are, so I can see where it's higher and lower. Nice. And so I can also change the colors on these. Okay. Interesting just to look at and play with. All right. I can also change contour labels. Here it's an automatic. Well, that's what I had before. But if I wish, for example, I can just put in none. And it won't tell me what these are. It's just sometimes a little bit easier to see the graph without numbers jumping up at you. But there are different controls I can put on there. Okay, let's go down to contour plot and shading false. So here again, I will get the default values on here, but just all in black and white. And if I wish, I can put in specific contours. This is exactly what we did back in 2D graphing to look at implicitly defined graphs. Okay, but again, I will get them for the two different contours I have there. Okay, and this is the 3/4, and that one is the 0 with the different colors. All right, density plot gives a lot of the same information, but it looks different. Okay, and I just get the shading in here, but I don't get any of the values. They'll kind of merge from one into another. And if I want here again, I can play with colors. There are lots of different options for solar colors. If you want, you can go up to palettes and start looking at color schemes, or you can go into the help system and look under color function to see which ones are built in. Now, region plot is very different. What this will do, I take my function, but I'm using the command region plot, that changes, but then I'm looking at where I want my function, under what controls I want my function to be graphed. So here I'm looking at this only when my sign is positive, and it will shade in those sections where the sign of x times y is greater than 0 and just ignore the rest of it. I can put in lots of different options in here, but I'm controlling where the function is graphed. Okay, well, I'm controlling what's true about the function. Those are the only places I want it graphed. We'll see a contrast to that in a different option later. I can put in lots more things. A double vertical bar is a logical OR. An AND is shown by a double ampersand. For example, I've used the double OR here. So where sign is positive or where sign is less than -2/3. Now, is that interesting? Well, you know, just to allow you to see that it can be done. All right. Some other useful options. here. We look at mesh first. Okay, 2D graphics. We looked at it very briefly, but in 3D you can do a lot more with this. First, let's look at our basic graph of sine xy, our nice example here, and mesh all. All right, now, many graphics programs for 3D will just show you vertical lines, lines parallel to the x-axis and parallel to the y-axis as it cuts across the graph and then smooths things out in between. And in fact, many, many years ago, that's what Mathematica did also. But there are now these little triangle things. And just with 2D graphing, where the graph is straighter, there aren't as many triangles here, but there are not as many points that are graphed. But where the graph is curvier, you get a lot more little triangles, and then it's smoothing things out within those triangles. So it's a much more accurate graph. It's a much more clear graph than what one can get with a lot of other basic software. All right, now, okay, let me look at mesh 5. All right, what this does is to take this in both the x and y directions and cuts this with 5 equally spaced lines, each parallel to the axes. So I've got 5 that go this way and 5 that go that way. So when you're looking at derivatives, or you just want to see, wait a minute, what's happening to that graph, I can sort of key in on, is it going up and down, and what's happening is x constant or if y is constant. Okay, but then we can play around with other things a little bit. Here I've put in mesh 3, so I want 3 different lines. But mesh functions, this is a pure function, number sign 3. 3 is because it's my third variable, x, y, z, and ampersand, that's part of the pure function notation. And so what I've got here is in the z direction, I have 3 vertically spaced lines between my min and my max. If I turn this around, you can see those. And so they're up on this part, but then they're also on this part of the graph, and we saw it before on the back. But 3 lines equally spaced between -1 and 1. Okay. Now, I can do some other things with mesh functions here. Here I'm looking at 5, so I want 5 different curves in this case. Now, well, those are curves too. All right, square root of number 1 squared, that's my x squared, and over here I have my y squared. So I want my mesh functions all on circles, evenly spaced. X squared plus y squared equals a constant. All right, so in this case, I'm going from 0 to 3 for x and 0 to 3 for y. So here's my origin back here. So this is my first part of my first circle. Here's my second one. Here's my third one. Fourth one's in there, and fifth one you just get to see part of, but these are evenly spaced outward. Okay, this notation may be a little anti-intuitive to some of you who aren't used to a lot more pure functions in programming, but you can see how it works and how it's done, and you may edit, just change the function and play with number 1 as the x value and number 2 as your y value. Finish it off with an ampersand. All right, next, region function. Now, this is in contrast to what we saw earlier. Where'd it go? Region plot. Oh, it's up here somewhere. There's region plot. Okay, it's up here. This was controlling what I know about my function. So I wanted certain restrictions on the function itself. When I come down here instead, though, so we're going to look at region function, I'm leaving my function alone. This is still plot 3D, but then I put in this command, region function. Okay, just watch the syntax. Function, x, y, and z. And now I'm controlling where I want my function graphed. So I'm not controlling the function itself or output of the function. I'm just controlling the domain of that. So my box is going to be -3 to 3 and -3 to 3 for y's, but I want this graph where on circles where the radius goes between √2 and √6. Not particularly nice numbers, but you'll get the idea and see it just fits inside my domain nicely. All right, so if I look at this from the top down, I've just got this graph on in between my two circles with those two radii. Okay, another example, and in this case I have two separate circles with an or in between. So logical or one circle or the other circle, or in between the circles actually. I've got four circles up here, but I'm looking in between them and just graphing it on those domains. And again, these functions, you can play with them a lot and put in different things. You can come up with some very creative graphs in the meantime. Okay, let's look at some more basic graphs here, just for interesting little things that can happen. Now, this will not be friendly around the origin because my function's not defined there. And this is where we start to look at continuity and limits and things like that. Okay, so another example in here with x over y cubed. So you can see where this gray is put in, where my function hits, where it goes off towards infinity, but it's hitting the top and bottom of my box. And again, I can control the range if I want to, but Mathematica just picks one for me. Okay, clipping style none. If I do that, then I just don't see the gray sections. I just see it going off, getting larger, and it just ends at the top of the box. On the other hand, I can put in lots of different colors and opacity and good things for my clipping style. So I've got two different sets here inside the curly braces, and the red in opacity 0.6 is for the lower limit, the bottom of my box down here, and then the yellow and opacity 0.6 is for the top of my box. Just if you want to. And a couple of other cute examples here. Sine of xy, uh-oh, that gets bad. Some extra plot points would help that, but you're probably going to need a lot. I'll skip that. You can try it now if you wish. Log of xy. I've got -1 to 1, so I've got the whole box, but I'm only graphing this function where x times y is going to be positive and in the domain of xy. And something else here, just playing with different graphs. Okay, well, just interesting things you get to look at, and of course spinning them around or zooming in and out a little bit makes it a whole lot more fun. As with two-dimensional graphs, of course, we can do parametric plot 3D. That actually is the command, parametric plot 3D, and I need my functions for x, y, and z, and then I need my domain here. I've used t as my variable, and I get a cute curve. Looks kind of nice. You can add plot points to that. Looks a little bit rough over there. That's fine. All right, some exercises. So let's look at a few of these. All right, plotting the graph of z equals x plus y over x minus y. So I want plot 3D, and I'm going to put in x plus y. And of course, you can use parentheses around that, but I'm going to highlight that and then use Control/ and get my denominator, x minus y. Get out of that, so I need x and y. I don't know. Let's just take x goes from -3 to 3 and do the same for y. Goes from -3 to 3. Not particularly exciting, but let me check that out. Okay, 1 over 0. Yeah, and so where x minus y equals 0, I've got some issues with this. Not a surprise. Green clipping style, yeah, it'll be pretty ugly, but it'll just remind you how to do this. Oops, sorry, typing. Clipping style, that's what I want. I won't try to type the rest of it. Green, ooh, this bright green something or other. Oh yeah, that is pretty ugly. That's okay. You can change the color if you'd like. Okay, next one. Z equals x squared over x squared minus y squared. So plot 3D of, we have x squared and over x squared minus y squared. Minus y squared. And get out of that cursor, move that over. And okay, some domain x -3 to 3, not particularly creative there, but that's okay. Y goes from -3 to 3 also. Does that look reasonable? Oh, sure. We get to see enough interesting stuff in there. Okay, partially transparent. All right, so let's do plot style. Sorry, plot style. And opacity. Opacity, and just to put in something, you can vary these, of course. You might want to play with that at some point. We'll see what that looks like. Okay, looks enough. I can see enough through there. And then add a color function. So color function and, oh, rainbow. Rainbow's good. Okay. And so I like my colors in there. It looks kind of nice. All right. But there, again, you're welcome to look under the help system and find lots of other color functions that are already in the system. Okay. So z equals arctangent of xy squared. Okay. Let's look at that. Plot 3D. And now, arctangent, there's nothing too exciting about this graph, but thought it might be a good reminder for the command arctangent, and entering that, and also reminding you that you need the space in between the x and the y squared. I've found that many of my students just kind of forget that on their calculators as well as on Mathematica. Okay, so there's our function, and let's go, x goes from, well, sure, -3 to 3 will work just fine on here. And then I'm going to look at region function. Region function and, oops, sorry, function. Excuse me, function. Put that in. You know, I don't remember all these things either and have to look at them sometimes and think about them, but gotten faster at doing that at least. So there's my x, y, z, close that, and I want x squared plus y squared less than 9. So x squared plus y squared and less than 9. Close my function off and then close my plot off. Uh-oh, because I didn't put my y's in there. Darn, that'll tell you. Comma, doop. All right, we're good. There's my graph. Sorry about that. Should have been thinking about it. Okay, so this one's much more calm than some of the other graphs I looked at. That's okay. Now, also says to look at a contour graph of this same region. Well, I can retype this with contour plot if I want. Right now, I'm just going to come down here, so I'm ready to start a new cell. And if I go back to insert, input from above, but I actually use the commands a lot on this. And I can just change plot 3D into contour plot. And then I don't have to mess up the typing and the coding again. That's good. And I will get a nice graph on that. I can change colors. I can do all sorts of other good things. All right, lots and lots to play with on 3D graphing and just interesting functions that you can look at. Thank you.